Welcome back to Summarize Science. Have you ever watched a caterpillar emerge from its cocoon as a butterfly, or an apple get sliced into pieces? Humans understand this is the same object changing form, but for computers, this is an incredibly difficult problem. Most AI trackers rely on an object's appearance, so when it changes drastically, they simply lose track of it. As you can see in these examples, existing advanced systems often fail, either missing the new objects entirely or being unable to connect them to the original. But a new paper introduces a system called TubeletGraph that aims to solve this. The core idea is surprisingly intuitive. Instead of just trying to follow the main object, the system first breaks the entire video down into a soup of tiny, short tracks of everything happening on screen. These are called tubelets. Now, when the original object seems to disappear after a transformation, the AI acts like a detective. It searches through all the newly appeared tubelets and asks two simple questions. First, is this new thing spatially close to where the old thing was? And second, is it semantically consistent, or does it make common sense? For example, a butterfly appearing next to a chrysalis makes sense. A bird appearing there would not. This clever filtering allows it to correctly identify and continue tracking the object, no matter how much it has changed. But it doesn't just track, it also understands. The system then uses a large language model to look at the before and after and generate a description of what happened. It creates a simple state graph that might say apple slice was cut into an apple slice piece. The researchers tested TubeletGraph against other state-of-the-art models on datasets specifically designed with transforming objects. The results show that their method consistently performs better, especially in the later stages of a video after the change is complete. Crucially, it is the only method that can both track the objects and describe the changes that occurred. So, let's quickly recap the important points. First, this system can follow objects even when they completely change their appearance. Second, it does this by cleverly analyzing all potential new objects that appear nearby using proximity and common sense. And third, it can generate a simple, human-readable description of the transformation. So, what could this mean for the future? Imagine kitchen robots that can truly understand a command like, slice the tomato and track all the pieces. Or think of automated wildlife cameras that can document an animal's entire life cycle, from egg to adult, without human intervention. This research is a big step towards creating AI that doesn't just see the world, but actually understands its dynamic and ever-changing nature.